even, I'd say, from the time of Weinberg back in the early 80s, but it's just now that it seems to be catching on in a big way. As a technologist, I would like to think it's all the neat technology that goes into these plants and the clever, innovative engineering and features and stuff, but it turns out today the real interest is they're cheaper. Goes back to that first slide. Customers need something that they can afford, and more importantly, something they can finance. And the big capital investment of nuclear power makes it really tough to think about these huge mega plants. So they're interested in a cheaper offering. Sure.
What usually counts is the cost per kilowatt installed, kilowatt electric installed, and that goes up as the plant gets smaller.
Maybe.
The reason to build
Maybe.
plants is to get that number down.
Yeah.
But there must be you wouldn't want to produce a 1 megawatt electric plant. That would just cost much too much.
Hold that thought, because I addressed that. And I've never given this presentation without somebody saying, you're all wet, economy of scale, nuclear has to be in big sizes.
I didn't say that. I said there's no limit to it.
But it is the common wisdom. It really is. And economy of scale is real, and let me address that. But this top line is the driving factor. It doesn't matter how much the cost of electricity is if you can't afford it to begin with. And it goes back to my first slide, the H1 Hummer. Yeah, if you can't afford it, then you're walking. So they need plants they can afford. And then there's all kinds of benefits that come from the technology. Obviously, they're smaller, modular, improved fabrication. You can build more of it in a factory, which is can be a huge cost savings, as well as improved safety and quality. Logistics of transport out to the site. I say enhanced safety. Actually, that's not a good way to say it. It's really the robustness. It's, all the plants are, even the big plants are safe. If you're talking about risk to the public, it's just that if you go back to the risk to the investor, what you want would be that plant to be as robust and resilient to the unknown as possible to protect your investment. And that's what I think the small plants have to offer, is more robustness. And then flexibility of applications. There's a whole lot of, particularly if you get away from base load electricity generation, if you think about process heat applications, many applications don't really need the full power output of a large plant. They would much rather have a smaller plant that would better match their energy demands, especially if you're talking about dedicated units for power sources for a, let's say, chemical plant. So it opens up the possibility for a lot of non-base load electricity, as well as special niche markets included there. The military, they're actually very interested right now and are actively engaged with us and DOE looking at the two drivers there to reduce their environmental footprint and to improve the energy security of their installations. And a small plant would be very well suited for something like that. All options are being looked at. I mean, it depends on the path forward you want to go. That might be desirable, or DOE still has the potential to license that. Again, I really ought to change the title here. It's really not safety benefits, it's robustness benefits. But it does, in fact, reduce the risk of a number of things related to safety, if you will. Since it's smaller power, smaller core, less fissile material, you're going to generate less fission products and nasties in the core, so your source term is going to be smaller. Now that assumes you're talking about a single unit. If you gang a whole bunch of these together, like NuScale, well then you're back up to the same. But on a per unit basis, anyway, it's a smaller inventory. Just from geometry alone, your ability to remove decay heat is a function of the surface area of the vessel, whereas your power or your decay heat is sort of goes by the volume of your core. So as you shrink it down, you're changing the surface to volume ratio in a way that makes it easier to remove the decay heat from the core. very passively just by cooling the outer side of the vessel. And all these plants take advantage of that. But I think that the most exciting aspect, and this takes me back into this deliberately small terminology, is that if you do your engineering cleverly, you can actually eliminate accident possibilities. And I've got a slide on that, and that's what all of those integral designs do. So let me explain a little bit better what I mean there. So here's your a model of your conventional PWR loop type design. This is what's out there generating power today. And sort of the accident that drove a lot of the engineering of these plants was, suppose, okay, so here's your reactor vessel, your core is in here, and then these are your steam generators. So your primary coolant water has to go from the